Hi there, and welcome back to another Papetti Math YouTube video tutorial where I'm going to be teaching you, the viewer of this video, Algebra 1. And in this video, what I'm going to be looking at is exercise number 5, found in lesson 2 of your workbook. And if you don't have a workbook and you're interested in purchasing one, you could go ahead and click on the link in the description of this video. Otherwise, it's nice to have you here and following along with this video. Exercise number 5 says, now that you have practiced solving one variable linear equations, you will practice creating your own equations from clues given to you in the following consecutive integer riddles. So we have this word here, consecutive. We need to know what that means. And consecutive means in a row. So a consecutive integer is just the next number, the next one in a row. So if we have an integer of 5, the next consecutive integer would be 6. And if we have 11, the next consecutive integer would be 12, and then 13, then 14, and so on. So in part A, it says the sum of 3 consecutive integers is 66. What is the largest of these integers? So we don't know what the integers are, so we're going to say, well, let's say that x is going to be our first consecutive integer. So let's think about how we could represent our second consecutive integer. So remember, a consecutive integer is the one integer right after the previous one. So what would be your next number after x? And if, remember, we looked at 5, and our next number was 6, how do you get from 5 to 6? The same way you'd get from 11 to 12, or 15 to 16, or 25 to 26. And that would be adding 1 to get to the next number. So if you have x as your first consecutive integer, x plus 1 would be your second consecutive integer. And these quotes mean just bring down the same thing that's above it. Which means our third consecutive integer would be, well, now we're going to take x and we're going to add 2 to it. That would be our third consecutive integer. Because we want 3 consecutive integers. And now it says the sum of those 3 integers, so sum means to add. So I'm going to add x plus 1 plus x plus 2. That's all 3 of these integers added together. And the result is going to be 66. And in order to find out what x is, I need to solve this equation. So the first thing I want to do is I want to combine like terms. So I see 1, 2, 3 x's. And I see a positive 1 and a positive 2, which will give me a positive 3, is equal to 66. So here we have a two-step equations. Remember, I want to undo the addition first. By subtracting 3 from both sides, I will be left with 3x is equal to 63. And my final step would be to divide by 3. And I'll get an answer of x is equal to 21. But remember, we always want to go back and answer our question that's being asked. And in this case, it says, what is the largest of these integers? So we found that x was 21. So this number right here is 21, which means the next consecutive number would be 22, and which means the last one would be 23. So the question's asking, what's the largest of these integers? And that would be 23, because that is the largest of 21, 22, and 23. So 23 is the largest. And now we go to part B. And in part B, we want to find 3 consecutive, now it's a little bit different, odd integers, such that the largest one is 1 less than twice the smallest one. So again, first we want to take a look at odd numbers. And we have 3. What's your next consecutive odd number? And after 3 comes 5, and then 7. What if we started at 13, though? Our next consecutive odd number would be 15, then 17. And then what if we started at, let's say, 71? Our next consecutive odd would be 73, then 75. So if our first consecutive odd integer was x, and I'm going to abbreviate it by consecutive odd integer to save space, how do I get to my second consecutive odd integer? So let's take a look at how we get to our second odd number all the time. So how do we get from 3 to 5? The same way we get from 13 to 15, the same way we get from 71 to 73. And you should be thinking that the way we do that is to add 2 to the odd number. So by adding 2, it will have us arrive at our next consecutive odd integer. And now finally, it says 3 consecutive odd integers. So how do we get to our third one? So 3 to 7, 13 to 17, 71 to 75, all of them involve adding 4. So x plus 2 and x plus 4 would represent our first, second, and third consecutive odd integers. Now we need to set up an equation to solve this. And it says such that, so this is where our problem really begins, the largest one is, okay, so the largest one right here, x plus 4, is, okay, equal to 1 less than twice the smallest. So less than means to flip the order around, so that 1 less than is going to be at the end of my expression on the right side. Twice the smallest. Well, the smallest one of these three is going to be the x, so twice x is 2x. And right here we have an equation that represents the largest consecutive odd integer is 1 less than twice the smallest. So now we're just going to solve this, and we're going to find the 3 consecutive odd integers. So again, we want to subtract the 4, get on the right side, and we'll have x is equal to 2x minus 5. Now we'll move all of our variables to the other side. So I'm going to subtract 2x from both sides. And I'll have all of my x's on the left side. And I'll have negative 1x is equal to negative 5. My final step would be to divide by negative 1. And I'll have x is equal to 5. Now going back, it wants me to find all 3 consecutive odd integers. So if x was 5, 5 plus 2 would give me 7, and 5 plus 4 would give me 9. So my 3 consecutive odd integers are 5, 7, and 9. Now finally, our last part of this exercise, number 5, is to find 3 consecutive integers, so we aren't concerned about odd or even this time, such that when you add the smaller 2 integers, the result is 5 less than the largest. So we're going to set up our let statements again over here. And since they're just consecutive integers, we're going to let x equal our first consecutive integer. I'll abbreviate. Let x plus 1 be our second consecutive integer. And let x plus 2 be our third consecutive integer. Now again, it says when you add the smaller 2, so of these 3, the smaller 2 are the first 2. So when you add those two, x plus 1, what's going to happen? The result is, that means equals, 5 less than means to take whatever's before it and put it at the end. So 5 less than, well, 5 less than what? The largest integer. So x plus 2 is going to go in front. The largest integer is x plus 2. 5 less than that would be minus 5. Now we're going to simplify some stuff and then solve for x. So on the left side of this equation, we could simplify by combining like terms. I see 2 x's right here. So I have 2x plus 1. And over on the right side, I have 2 constants that I can combine together, and I'll get x minus 3. Now again, I'm going to move all my variables to one side, all my constants to the other. So I'm going to go ahead and subtract the 1. And I'll be left with 2x is equal to x minus 4. And finally, subtract x from both sides to get all my variables on the left side. And I'll have x is equal to negative 4. So now that I know that x is equal to negative 4, I could go back and see what my other consecutive integers are. So I have negative 4. Negative 4 plus 1 would be negative 3. And negative 4 plus 2 would be negative 2. So my 3 consecutive integers would be negative 4, negative 3, and negative 2. So my answer would be all 4 of these because it's asking for all 3. And those are my 3 consecutive integers, such that when I add the smaller 2 ones, the result is going to be 5 less than the largest one. So if this video was helpful in solving consecutive integer riddles in Algebra 1, give it a thumbs up below. And now you're ready for Lesson 3 in the first chapter of Algebra 1, Introduction. Thanks for watching.